Hello, calculus students, and welcome to the most important lesson in all of calculus. This is on the fundamental theorems, plural, of calculus, the FTC. Okay? And in order to get to this theorem, we're going to have to build up to it in small little increments. So there's going to be a lot of things in this lesson that seem very unusual and weird and disconnected, but I promise you at the end I will weave it all together into the spectacular theorem and result that this really is. But let's start with our first little breadcrumb here. Given f of x equals sine of x, find a point C in the interval pi over 4 to pi over 2, where f of x's average rate of change is equal to its instantaneous rate of change. Okay, so let's work through this. So the average rate of change is just f of pi over 2 minus f of pi over 4 over pi over 2 minus pi over 4. Let me write that out. Okay. So in other words, this is just the slope of the secant line. Okay. Now let's calculate that. So f here is sine, so sine of pi over 2 is 1 minus sine of pi over 4 is root 2 over 2. Pi over 2 minus pi over 4 is, of course, just pi over 4. So this is 1 minus root 2 over 2 times the reciprocal of pi over 4, or 4 over pi. So this will be equal to, okay, so that's 4 minus 2 root 2 over pi. So that's the average rate of change. We want to find some point here where the instantaneous rate of change is equal to the same thing. So let me just draw you a picture. This is the sine function. Pi over 2 is right here. And pi over 4 is right here. And that's this point. And this is this point. Whoops, I'm drawing way off the screen here. And what we're really saying is here, there's a slope. This slope right here is equal to 4 minus, so this slope is equal to 4 minus 2 root 2 over pi. Okay? And we know that there is some other point in here somewhere where the instantaneous rate of change is exactly equal to the same thing, and we want to figure out what the value of C is. So the instantaneous rate of change, well, that's just the derivative, so f prime of x is equal to cosine of x, and then we know that so cosine of C must be equal to the rate of change here, the average rate of change, 2 over root 2, all divided by pi. And once we work all that out, we will get cosine inverse of this mess right here would be equal to C. And that is about, C is about 1.189. Okay? So this point right here is where the average rate of change in this interval, pi over 4 to pi over 2, is exactly equal to the instantaneous rate of change. Okay? And maybe I should ask you a follow-up question. You know, what theorem is this? What theorem does this question illustrate? And I'll leave that hanging there. If you can't figure it out, ask your teacher. It's a very important theorem. We will get back to this soon enough. Okay? So there you go. This is just the warm-up. Be sure to watch the next series of videos that walk us through all of the development that leads to this fundamental theorem, which at the moment we don't even know what it is yet.